Hello everyone, welcome to DKodeTree. Let's solve LeetCode 2563 count number of pair pairs today. Given an array of size n, we have to find the number of pairs that satisfy the given condition. That is, the sum of both the numbers should lie between a given lower bound and upper bound. And indices of both the numbers should be in order, that is I less than j. This ensures that we don't check a pair more than once. The easiest way to solve this problem is by iterating over each pair of given numbers and then checking whether they satisfy the given condition. This is the brute force approach which runs in O of n squared time, as we are using two for loops and iterating over all the possible pairs. But let's see if we can do any better than this. One thing to note is the given input is not in sorted order. Let's see if sorting makes it any better. So these are the same numbers in the sorted order. After sorting the input, it reminds me of another problem, that is the 2 sum 2, where the input array was sorted and we needed to find a matching pair to a given target. In that case, it was very easy to use the 2 pointers method, and that gives me a hint that we may also be able to solve this problem using 2 pointers. But in this case, we have two bounds, one is lower and upper bound, which is making the things more complex. So let's take one bound at a time and try to simplify the problem. For the entire array, if we can find the total number of pairs only based on the upper bound, then the problem becomes simple. Say our left pointer is at 0 and the right pointer is at 7. So let's check 0 plus 7 is less than equal to 6 or not. So this does not follow this condition. That means the sum is not up to the upper bound. So we have to move the right pointer to the left, that is decrementing it. Now let's check if 0 plus 5 less than equal to 6 or not. And this actually satisfies. This implies that any number less than 5 will also satisfy this condition. So from this condition we can find the total number of pairs which includes 0, so that the sum of the pair is less than equal to 5 using this simple equation r minus l. So I have noted down the indices also for ease of calculation. So in this case, r minus l will give us 4 minus 0, that is equal to 4. Similarly, now we have to move the left pointer to the right. So now we have to check if 1 plus 5 satisfy this condition or not. So it still satisfies this condition. So we can also count the number of pairs which include 1 and whose sum is less than equal to 6. So that will be 4 minus 1, that is 3. So after this we will again move the left pointer. Now we will be checking 4 plus 5 less than equal to 6 or not, and this does not satisfy. So in this case we will again move the right pointer, as the sum is going over the bound that we were checking for. Now our right pointer is at third index. So now we have to check if 4 plus 4 less than equal to 6 or not, which still does not satisfy. So we will again move the right pointer. But now with only a single value we cannot form a pair. So we will stop the iteration here. So now if we add 4 and 3 we will get 7. But this total number is only considering the upper bound and not the lower bound. So now we have the total pairs where sum is less than equal to 6, that is the upper bound, and that value comes down to 7. So the answer is definitely going to be less than 7, but this answer includes all the pairs which are actually greater than the lower bound as well. Say on a number line, we have all the pairs whose sum is less than equal to 6, and that we have calculated as 7. So our answer will definitely be less than this. But the thing to note here is we need the total pairs whose sum is greater than equal to 3 as well, along with being less than equal to 6. So 3 is somewhere here, and actually our result will include this part and not this total part. So one of the easiest way to find this number is to calculate this section and then subtracting it from the total. So what is this area? This is actually total pairs with sum less than equal to 2, which is 1 minus the lower bound. Because this section includes anything that is equal to 3 as well. So if we consider 3 minus 1, it will be easier for us to solve the problem, and we can reuse the code that is written for calculating this total value. So our final formula comes down to total pairs with sum less than equal to upper bound minus total pairs with sum less than equal to lower bound minus 1. And as we can find this in O of n time using 2 pointers, so we can find this as well in O of n time. But to remember, as we are sorting the input, it is taking O of n log n time. So here, in this case, sorting is actually dominating the time complexity. Time taken by the entire approach will be n log n in this case. Similarly, the space complexity also depends on the way the sorting method is implemented. So if it is implemented in place, it will take O of 1 space, but if it uses extra space, then it can take O of n memory complexity. In Python, the inbuilt sort function generally works in place. So let's jump into the coding part. So let's start with sorting the input, which we can easily do using the sort function. We will define a helper function here, which will count the pairs, which will take a upper bound as input, and will return the count of pairs with sum less than or equal to this upper bound. So let's first see how we will use this count pairs function. In the result, we will be returning the count pairs of upper minus count pairs of lower minus 1, as we have seen in the drawing explanation. So now everything boils down to implementing this small function, where we will use 2 pointers, left and right. Left will stay at the 0th index and right is initialized with the last index. We will take a count variable, and finally we will be returning the count variable from this function. Now we will write a while loop which will run while the left is less than right. Let's calculate the pair sum. It's equal to nums of left plus nums of right. If the pair sum is less than equal to the upper bound, then we will add the count of pairs with sum less than or equal to the upper bound, which includes the left value, that is right minus left, and then move the left pointer by 1. And if it is not the case, we will simply move the right pointer by 1, that is decrementing it. So this was all the code that we wanted, and now let's run it and check if it works. So this works fine and it is quite efficient. The analyze complexity of LeetCode is working pretty well, I think. If this was helpful, do consider liking this video and subscribing to DKodeTree. Thanks for watching. See you in the next video.